Math and Beats. In this video, we're going to come up with the general derivative of an inverse function. Let's go. All right, we're going to assume that we got a function f of x, and that function is 1 to 1. Of course, if a function is 1 to 1, then its inverse function, f inverse of x, exists. Our goal is to determine what the derivative of such an inverse function is in general, and we should expect that in one way or another it should be related to the original function f. So, because we know that f of x, this function that we're beginning with, is invertible, then of course, if I compose f with f inverse of x, I get x, assuming that all the right conditions check out, everything's defined in 1 to 1. So, if I go ahead and differentiate both sides of that equation above, then the derivative with respect to x of f inverse of x is going to be equal to the derivative of x with respect to x. Now, of course, right-hand side over here to the right, it's just 1, right? Derivative of x with respect to x. But then on the left-hand side, we have a chain rule involved, and thus we need the derivative of the inner function f inverse of x with respect to x times the derivative of the outer function, which is just f prime, and that, of course, depends on what f is, evaluated at the inner function, and thus we get that statement. And now if I simply divide both sides by f prime of f inverse of x, then I get that the derivative of an inverse function f inverse of x with respect to x is 1 divided by the derivative of f prime of f inverse of x. And guess what? That's the result. That is what we were looking for. That's the general formula for the derivative of an invertible function, f inverse of x. So we should see it in action. Let's see it in action here. Let's use that result that we just established to determine the derivative with respect to x of the arc sine of x, or sine inverse of x. So just so we have it on screen, remember the derivative with respect to x of some invertible function, f inverse of x, is 1 over f prime of f inverse of x. Now in our case, we have arc sine of x that we're differentiating, and so here you should think of f inverse of x as sine inverse of x. And that would imply that f of x should be sine of x, because that's its inverse. And so, what is f prime of x here? Well, it's just the derivative of the sine function, which is cosine of x. And thus, the derivative of the arc sine of x with respect to x should be 1 over the cosine, that's our f prime, evaluated at sine inverse of x, which is our f inverse of x function here. Now that we need to simplify. In fact, we've already established what the inverse sine function's derivative is. However, we can show it's the same thing by simplifying that expression right there. Let's go ahead and draw a right triangle such that we have this situation. That is, sine inverse of x is just some angle such that sine of the angle is equal to x, which is x over 1. So the sine of this angle, opposite over hypotenuse, x over 1, and we need to find that adjacent side because we need to take the cosine of that angle. And so by Pythagorean Theorem, L squared plus x squared is equal to 1, and L squared is going to be 1 minus x squared, And then, of course, L is going to be the root of 1 minus x squared, keeping in mind that we're assuming that this length here is a positive number. And so the whole point was to rewrite what we just established right here, right? The cosine of that angle in the denominator, we get that the cosine of that angle, just off on the side here, wouldn't it follow then that cosine of this angle theta adjacent, which is, of course, the square root of 1 minus x squared that we just established, over the hypotenuse, otherwise known as just square root 1 minus x squared. And thus, 1 over the cosine of that angle is 1 divided by square root 1 minus x squared. And there's our derivative. There's our derivative function, the derivative of the sine inverse of x. And so as you can see, this established general derivative of an inverse function works. We proved it, and we just showed an example. We verified a previously established result. And there you go. There's just one example. You could do this for any inverse function. And that, my friends, is the end of this video. And so until that next video, this is Math and Beats, and I'm out of here.